All right, guys. So this would be the first lesson of the class here. We kind of jumped through the review part, so we're gonna get straight to the graphing and the function part of this class at the beginning of the semester. 2.1, we're gonna briefly review just the basic graphing method that we learned in Math 100 or um, beginning algebra. This class is intermediate algebra, so we're going to review a little bit of the method we learned in beginning algebra. That was graphing an equation using a coordinate system. It's called rectangular coordinate system here. So this is also called the Cartesian coordinate system. So this was named after the mathematician that come up with this. So it's a system we use to graph two-dimensional shape or objects or lines in this class, lines and curves. Um, so we have the horizontal axis. This is called the x-axis, if you remember, and then we have the vertical axis. This is called the y-axis, right? And we have four different regions here. These we can call them quadrant. So quadrant. So quadrant. So in this case, we have quadrant 1, and then here we quadrant 2, and here we quadrant 3, and here we quadrant 4. So, and then the point in the middle here, this is called the origin. Okay. So for the x-axis, this is actually has two real number line kind of combined together. So in the horizontal axis or the x-axis, we have the scale go from negative to positive. So if this is 0, then this would be positive 1, positive 2, 3, and so forth. So this arrow means gonna keep going indefinitely. And here we have negative 1, negative 2, negative 3, negative 4, right? And then on the vertical axis, we have a positive on the top, 1, 2, 3, 4, and so forth, and then negative in the bottom. Okay, here it is. All right. So we got the quadrants. We have the x and y axis. We have the origins. We have the so this is also how we use to identify the signs of an ordered pair. So notice that if I do a dot or a point right here, let's say here's the point there. So that point there would have, if you are here, if this dot here is this position, so that position there is 4 unit on the x-axis positive, and then 2 units on the y-axis. So we can say, all right, that location there is 4 comma 2, and then we call this here is an ordered pair. So this is an ordered pair. All right, we have the x and the y. X is the first coordinate, and then the y is the second coordinate. All right, this is the second coordinate. All right. Oh, excuse me. Let's see here. So if some points where they're not in these quadrant, let's say we have another point. Let's use this one right here. So let's say we have another point right there. So that point there will have no horizontal unit at all. It's right in the middle. So we're going to say it's going to have the x-axis, x coordinate is 0, but it's down 3 units from the vertical axis. So it's going to be negative 3 for the y coordinate. So in this case here, this point here, we can name these point by these location. Let's say this is point P. So point P. So point P has a coordinate 3, negative 0, negative 3. So in this case, point P here is not in any of the quadrant. It's actually on the y-axis. So we say point P is on the y-axis. Okay. Let's plot a few more points. So let's say we plot. Let's do some decimal and fraction. Let's do 3/4 and 1. Okay, so let's call this point here Q. Okay, so Q, let's say Q is 3/4 on the X, so 3/4 is less than 1, so maybe here's half, and that's 3/4 there. And then 1, maybe 1 is up here, so here is our point Q there, right? So that's 3/4 and 1. Let's do a decimal. Let's say we're going to apply point R, and point R, let's do point R is 0.5 and negative 2.3, for example. Okay, so let's see. All right, so R has the coordinates of X is 0.5, so 0.5 is right there, right? And then the Y coordinate, here's X, here's Y, and the Y coordinate is negative 2.3, so we're going to go down 2 units from the Y-axis direction, and then a third, so negative 2.3, let's say here's negative 2, negative 2.3, I would say around here somewhere, right, because it's less than 2.5. So that point there, we can call this is R, with the coordinate as 0.5 and negative 2.3. Okay. So that's pretty much the basic thing that we learned from Math 100. It's just what is the rectangular coordinate system, how do we plot it, how do we identify the quadrants, which direction is negative and positive. Let's get into some example how to graph a certain equation. So let's look at this equation, this one, and this one. So these are the examples I want to go over in this video here. All right. So another thing we learned is how to graph equations. So let's say here, so example 1a. So we want to graph these equations. Okay. So let's say A, we want to graph y equal to 2x minus 1. Is that the example? Yeah. Okay. So in Math 100, we learned that graphing these equations, another way of interpreting what that means is geometrically, when we graph this here, we're going to have a line. That line there is going to represent all the solutions for this equation. All right. So this equation had two unknown variables, x and y. X being the independent variable and then y being the dependent variable. So for every given x, y is determined, y is dependent on that, right? So we said I can sketch my solution using this x and y table, right? So I'm going to say, okay, well, if I choose x to be -1, then y can be computed by plugging to the equation for x. So that's going to give us what? 2 times -1 is -2, minus 1 is -3. So our first order pair we have here is -1 and -3. So we can say this order pair is a solution to this equation. Let's do 2 more points. So we have, let's say if I pick x equals 0, and then in this case y is going to be -1. And if I pick x equal to 1, then y in this case is going to be 1 itself. So we have 3 order pairs. Okay. So we can say these are the solutions. We can say these are the solutions, to this equation. They're not just 3, they're infinite many solutions. It turns out that lines have infinite solutions. Meaning, you give me an x, I can figure out y, right? So it doesn't have to be whole numbers. We pick whole numbers to get the pattern here and graph the equation, but it can be decimal, fractions, and anything you want, okay? So we also learned that in order to graph this y equal 2x minus 1, we just plot these 3 points, okay? So let's say we have -1 and -3, so that's -1 on x, -3 on the y. So here's the first point. 0, -1, so 0 on the x, -1 on the y, so that's our second point. 1, 1, so that's our third point there. And so now we connect these 3 points and we make a line. Okay. All right, so there it is. And we have this arrow here, remember, right? We draw this arrow at the end. This means the line keeps going indefinitely in both directions. It means that anything on this line is a solution to this equation here. So we only found 3 particular solutions to get the pattern of the line, and we graph it. So this line here, this graph, okay, so we say that this graph here, this line, right, represent all possible solutions, and the solution is going to be in order pairs of the equation y equal to x minus 1. So that's what graph means. It's just a visual way for us to interpret what would be the infinite possible solution for a particular equation with two unknown variables x and y. Okay, so this is the method we learned in Math 100. This is called by plotting, pretty straightforward method. And then as we progress through the lesson or the course, we learn more advanced method or much better, because some equation is not so some equations can be tedious to do all of this here. Okay, so that's how we graph line. Let's use plotting again to graph another equation. Let's say we can do, let's do negative 1/2 x. Let's do that down here. Let's do part B. All right, so the equation we want is negative 1/2 x. So let's pick a few points again. All right, you can choose any points you want to. Preferably pick the point so that way you don't have to do a lot of math. In this case here, if I pick x equals 0, my y is going to be 0, so that's going to be an easy solution, easy point there. Another one is if our coefficient is negative 1/2 for an x, when I plug in an x value, I need to divide by 2, so perhaps I can pick a a negative 2 or anything in multiple of 2. So if I do this here, I get my y to be 1, right? So now I can do a positive 1. Let's do 4. So if I pick x equal to 4, negative 1/2 times 4 is going to be negative 2. Right? So here's all my 3 points. We have 0, 0, negative 2, 1, and then 4, negative 2. So I picked, some variety from negative to positive x value there to see what the line looks like. So now we're ready to plot these points and connect these points to make a line here. So 0, 0 right there, negative 2 and 1 is there. All right, and then 4 and negative 2, so it's over there. So we're ready to connect these to make a line. Okay. So now I'm just going to connect these points here. All right, there it is. And then again, this line doesn't stop at those points. We draw this arrows at the end to indicate the line keep going indefinitely. So notice that this line in part A compared with part B here. So you see how like this line here rises from left to right, and then here this line here in part B, it kind of like fall from left to right. So we can say rise from left to right, and we can say here is falls from left to right. In the next couple lessons, we're gonna learn that certain lines will have certain indication of steepness, and those steepness can be identified by this coefficient from x. And if this coefficient is positive, we have the rise from left to right, and if that coefficient is negative, we have this fall from left to right. And to summarize that up, you're probably familiar with this, and we call that slope. Is referring to slope is referring to the steepness of a line. Okay, and then we learn all the different methods to graph a line, where we don't have to do this plotting over and over again. Okay, let's look at one more example. One more. Okay, I'll let you guys figure out this one on your own. I'm gonna review a little bit the parabola there. So let's do that part C, and then I'm gonna go ahead and move this down here. All right, so okay. So C, I want to graph y equal to x squared minus 4. Another graph you may see in Math 100 or the class before this is a parabola. So we call this is parabola, right? Or later on we learn that these parabola will have a more formal name. We call these a quadratic. Okay. All right, so let's use our plotting method again to get a pattern or a graph of this equation here. So plotting method is the most basic method that you can start if we don't know what the shape of the graph look like. So as we pick this x and y, we start filling up these solutions, and perhaps it reviews some sort of pattern of the line. So we're gonna say graph by use the plotting method. All right, so this is the most easy one. So when we do this here, we create an x and a y table. We call this x and y table. So we pick an x to get a y. So let's say if I want to pick x of -1, then I plug that into the equation. So -1 squared minus 4. So that's going to be 1 minus 4, which is -3. Right? So here it is. I got my first point. -1 and -3. That's my first point. So my next point, I'm going to pick 0 for x. 0 squared minus 4, that's going to be -4. So 0, -4 is 1, 2, 3 is my second point. If I pick x equal to 1, then I'm going to get 1 squared minus 4. We're still going to get -3 here. So we got 1 comma -3 there. Let's pick 2 more points. So I'm going to pick a 2. So we got 2 squared minus 4. So that's going to be 4 minus 4 equals 0. So when x is 2, y is going to be 0. And I'm going to guess that when x is -2, the y is going to be 0 as well. So I'm going to guess that. You can check on that one, okay? So, if you've seen this before, you know what the graph's going to look like. But it's very misleading to think that the graph will look like this here, okay? Where the connection between these points can be a straight line. It's not. It doesn't behave like that. If we have time, we can actually pick a lot more points. Like let's say we pick point 5, maybe here, or even point 1 or point 2 or negative that. Pick some decimal. So and then you get the y value. You're gonna see that the graph, the curve itself is not gonna be straight between these points. It's actually it's gonna behave very smoothly. It's gonna be like this. Okay, so it's going to be smoothly around those points. It's going to go up, draw an arrow, go up, draw an arrow. So it's going to be that type of pattern versus something like this here. So that right there is going to be this example here when you try that on your own. Okay, so parabola needs to have some sort of curve around these points here when you do an XY table. Okay. In chapter 8, we learned the translation of the graph. We learned that given this here, we can actually look at that and know what the graph looked like right away without doing all this, all these methods here. Okay. All right, so I think that's pretty much all the example I want to cover in this first lesson. Pretty short, short lesson here. So let me know if you guys have any questions.